Hi students, this is Sivakumar, 12th Standard Business Mathematics and Statistics, Chapter number 1, Continuation of Exercise 1.1. We are finding a rank of the matrix. Already I completed how to find rank of the matrix by minor method. Now, how to find a rank of the matrix by row echelon method. Row echelon method. Read that. A matrix A of order m cross n is said to be in echelon form. Say echelon form if every row of the matrix A which has all its entries 0 occurs below every row which has a first non-zero entry. That is very important. First non-zero entry. Second subdivision, the number of zeros before the first non-zero element in a row is less than the number of each zeros in the next row. While doing the problem, you can easily understand, right? Now, exercise 1.1, question number 1, subdivision 6. Particularly, this method is applicable if you are given a rectangular matrix, right? That is, look at the number of rows and columns. Number of rows and columns are different. That is called a rectangular matrix. Now, order of A. Start with the order of A. How many rows, how many columns? 3 rows, 4 columns. 3 rows, 4 columns. We can do this problem in minor method also, but it will be somewhat lengthy. So, instead of going for minor method, we can go for row echelon method. That will be easy for you. After that, write rank of A which is less than or equal to minimum of 3 and 4. 3 and 4. That is rank of A which is less than or equal to minimum of 3 and 4, 3 only. So, less than or equal to 3. So, the rank of the matrix can be either 3 or 2, even 1. Now, how to find? Let A here it is. The next step you have to write equivalent of. In this method, the first row, first non-zero element, here it is. First row, first non-zero element, right? Below which all the elements to be changed into zeros, so that you can go for transformation. So, since the first row, first element is 1, write as it is. First 1, 2, minus 1, 3, no change at all. So, under that number 1, 2 numbers are there. What are they? 2 and 3. I am going to change 2 and 3 into zeros. So, R1, no change. I am going for row transformation that we have learnt already in 11th standard. For making this element as 0, so using this row, that means 2, it has to be minus 2. Then only can get 0. So, that R2 implies R2 minus 2R1. Right? If you multiply this element by minus 2, you'll be getting 2 and minus 2. 2 minus 2 equals 0. Right? I do the calculation here. That will be easy for you. So, rough work. Listen carefully. What I have written here, R2. Write R2 as it is. 2, 4, 1, minus 2. I am going to multiply R1, each and every element of R1 by minus 2. Right? Multiply 1 into minus 2, 2 into minus 2, minus 4. Minus 2, minus 4. Minus 1 into minus 2 is plus 2. 3 into minus 2, minus 6. 2, minus 6. 2 minus 2, 0. 4 minus 4, 0. 1 plus 2, 3. Minus 2, minus 6, minus 8. 0, 0, 3, minus 8. Right here. 0, 0, 3, minus 8. right? We have changed that number 2 into 0. Previously it was 2, now it has been changed to 0. Like that, even 3 has to be changed to 0. Already I told you, under the non-zero, first non-zero element of the first row, the two numbers 2 and 3 should be changed to 0. Now 3, or 3 implies, here 3, it has to be minus 3. Then only if you add the two numbers, you will be getting 0. So that, or 3 minus 3 or 1, right? Or 3 write as it is, rough work. 3, 6, 3 minus 7. I am going to multiply R1 by minus 3. Here R1, multiply each and every element by minus 3. 1 into minus 3, minus 3, 2 into minus 3, minus 6, minus 3, minus 6, minus 1 into minus 3, plus 3, 3 into minus 3, minus 9, 3 minus 9, 0, 0, 6, minus 16, 0, 0, 6, minus 16, 0, 0, 6, minus 16. Once again put equivalent symbol, not equal, equivalent symbol. Write the first row as it is, no change at all, 1, 2, minus 1, 3. And even second row as it is, 0, 0, 3, minus 8. In the second row, which one is the first non-zero element? Here is the first non-zero element, correct? First non-zero element. Below which there is one number. What's the number? 6. We have to convert 6 into 0, right? How to change? Before that, look at the third row. We have 0, 0, 6, minus 16. These four numbers can be divided by 2 or 3. We can divide by 2, right? So I'm retaining R1 and R2, R3 to be changed, R3 divided by 2, or even you can write half R3. That means each and every element of R3 should be multiplied by half. Half into 0, 0. Half into 0, 0. Half into 6. Half into 6, that is equal to 3. Right, 3. Half into minus 16. Half into minus 16, that is minus 8. Right, minus. That will be easy now. Now proceed. Write the first row, 1, 2, minus 1, 3. Even second row, no change at all. R1, R2, no change. Now in the second row, here is the first non-zero element. I am going to change under that number 3. Here there is a number 3 that has to be changed into 0. What to do for that? R3 implies R3 minus R2. You can directly, if you subtract, you will be getting 0, right? 0 minus 0, 0, 0 minus 0, because R3 minus R2, 3 minus 3, 0, minus 8, minus of minus 8, that is plus 8, that is also 0. For your reference, I write here R3 minus R2. What is R3? 0, 0, 3, minus 8. R2, each and every element of R2 should be multiplied by minus. Here is R2. Multiply by minus, 0 becomes 0, 0 becomes 0, 3 becomes minus 3, minus 8 becomes plus 8. 0, 0, minus 3, plus 8. 0, 0, 3 minus 3, 0, minus 8 plus 8, 0. So that I written here all 0. Now, it is in echelon form. This is called echelon form, right? After that, how to write the rank of the matrix? We have to count how many number of non-zero rows. This is a 0 row because all the elements are 0. That is called a 0 row. If any one of the element is a non-zero, that is called a non-zero row. Look at the second row. Even though here we have double 0, here this is non-zero number. Therefore, it is called a non-zero row. It is also non-zero row. So, how many non-zero rows? 2. That is the rank. So, rank of A, that is equal to 2, since it has two non-zero rows. That's all, students. We can continue the next subdivision in the next class.